So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, we talk a lot about batteries, mostly lithium-ion. The pricing of lithium-ion batteries is being driven by the auto industry, continually declining as the volumes go up. But lithium-ion chemistries are not ideal for long-term energy storage. And there's also longevity issues. They degrade over time. Batteries wear out. We all know that because our electronics only last for a few years before the batteries are too dead. So there's another technology out there called flow batteries. They use a liquid electrolyte that flows between the anode and the cathode in the battery, and the energy stored in the electrolyte. That electrolyte stays in one or two big tanks and easily extracted when needed. So when you need the power, you pump the juice backwards and you get energy out of it. Now, it's great for grid scale storage and really big storage systems, particularly PV systems and wind. You can site the batteries in the fields near the panels. You got plenty of space available. It means that inverters also, they don't have to be as big, because if you have a battery that can soak up the extra power that's coming from this big solar array, you can charge the battery up instead of changing it into AC power and then sending it to the grid. So you can reduce the cost of the inverter. Now, Avalon is one of the leaders with this new battery technology. Now, I heard about them from my friends at Nextracker. They got a very cool demo and technology, and I said, I got to get somebody from Avalon on one of my radio shows. So my guest this week is Matt Harper, founder and chief product officer of Avalon. He was previously with Prudent Energy, and he has a couple of degrees from that small technical college in Cambridge. So welcome to the show, Matt.
Thanks very much, Barry. Great to be here.
Right.
Thanks for the introduction.
All right, great. Well, a lot of our listeners are going to say, gee, what is a flow battery? How does it work? I gave kind of a lame explanation, but you're a heck of a lot more detailed on that.
Sure. Well, look, fundamentally what a flow battery is the same sort of charge and discharge reaction as you would get in a conventional battery. The difference is that the energy in a flow battery is stored outside of the cell where the charge and discharge actually happens. And what that means is two things. First of all, you can, because your stored energy is in these, external tanks, you can store a lot more energy without adding a lot of extra cost to your battery. But also, because you're taking that energy off into, a storage area outside of the cell itself, it means that you can very effectively manage the sort of the chemical reactions and some of the additional byproducts like heat that you get out of charging and discharging the battery. So it allows you to store a much larger amount of energy as compared with a conventional cell at very incremental additional cost. And you can do it in a very, very controlled way where you get a much, longer life out of the battery.
All right, so cool. So theoretically, if I wanted to have a flow battery for a home, I'm just making this up, but, I might have a 10-gallon storage tank, maybe the size of a fish tank. But if I wanted a flow battery for a company, a bigger system, that might be a 1,000-gallon tank or bigger. Maybe utilities are going to have a 10,000-gallon tank. I'm just making up these numbers, but just kind of scaling, you just put a bigger tank in, you can store more energy.
That's exactly it. I mean, think of it like the engine in your car and the gas tank in your car, right? You want to go faster, you have a bigger engine. You want to go longer, you have a bigger tank. A flow battery allows you to optimize those two things separately. So if you want to run a really, really long time, you can do that by simply making the tank bigger.
That's cool. All right, so everybody hears about lithium-ion batteries. I mean, I drove here in a car powered by a lithium battery. For what applications is a flow battery better than a lithium-ion battery?
So for a lot of the applications that we're seeing today for lithium, lithium's a great solution. You talk about, your car. I mean, that's a great way. That's a great way to use lithium batteries. You talked about, in your intro, our electronic devices, right? I mean, that's a great application for lithium because, fundamentally the technology in your phone is only going to last a couple of years anyway. Why have a battery that lasts any longer than that? The difference is, now that people are starting to talk about energy storage as a component of power generation. So whether you're putting solar on the roof of your house or whether you're talking about, these massive utility scale generating plants that are being built out in the desert, those assets are being designed to operate for 20 to 30 years without being replaced. And current battery technologies haven't been designed that way. They simply don't have the kind of longevity that's needed to match the life of those renewable generating assets. And so what our battery does is it brings that level of longevity into the battery space, where we can do, daily discharges or multiple full discharges of the battery per day. And we can do that for decades as a way of optimizing the production from those renewable generation sources.
So it sounds too good to be true. I mean, my lithium-ion batteries that we're putting in for businesses and homes, there's a rock-solid 10-year guarantee, but nothing beyond that. So if vanadium flow batteries are going to last longer, is there anything that wears out? Does that electrolyte ever have to be replaced, or can it be recycled?
Well, the electrolyte never has to be replaced, and in fact, it's one of the great advantages of our particular flavor of flow battery. The working material in our flow battery that actually stores the energy is a metal called vanadium. And what's wonderful about vanadium is that it and only it is the element that holds the energy inside the battery. But at the end of the battery life, whether that's sort of 20 or 30 years out, that vanadium is still there. It hasn't changed at all over the life of that product. And you can take that vanadium away and you can reuse it in other applications. It retains exactly the same amount of value as you had on day one.
So why vanadium? What other industrial process or tools or metals or combinations are using vanadium, and how's the world supply of vanadium? Because I know that cobalt and lithium is we're running out, or it's getting tighter.
Sure, yeah. Well, look, I'm willing to bet that if you went to your garage and pulled out a wrench, you'd see the word chrome vanadium written on the side of it. Vanadium is used primarily as a strengthening element in steel. And so, for example, steel, hand wrenches have vanadium added to them so that they can be as strong as possible. 90% of the world's vanadium goes into steel manufacturing. The other uses are primarily strengthening of things like titanium. And if you're a cyclist, you've probably seen the letters 6V. 4Al on the side of a titanium bike component. That means it's got 6% vanadium in it. Vanadium itself it's a pretty common material. It's the 12th most common metallic element in the world. It's more common than other things like nickel or copper, for example. And it's available all over the world. Extraction sites for it, all over the world. It's sometimes pulled directly from, mines or similar operations, particularly in support of steel manufacturing. But it's also produced as a byproduct or as a waste product from industrial processes like oil refining.
Okay.
So you can go to your local oil refinery and find waste products that has a lot of vanadium still in it. That vanadium can be extracted, and so you're not only generating, a new revenue stream or a new source of useful stuff, you're also getting rid of a waste product as well.
All right, that makes sense. I'm going to lose the bet because the only two places I ever saw the word vanadium before I started talking to you guys was on my tools and also on the periodic table. It's in the tools, so I kind of get it. Now, tell me about the packaging of the flow battery and where is the inverter in the battery? How does that all kind of work together?
Look, it really depends, like any battery system, it really depends on what you're intending to do. We sell these systems for everything from, small commercial and industrial project sites all the way up to kind of utility scale power generation. For the smaller projects, typically what we do is we have an inverter that we mount directly onto the battery. Often that inverter is a design that is able to take power from not only the battery, but also from PV array on site as well. So you're kind of combining those two devices together. You don't need to buy a separate inverter for both your PV and your battery. And, when you start to look at, larger, utility scale installations, typically those will use, much larger kind of central inverters. So you would take a whole bunch of these batteries together and then connect into a single inverter on site.
Yeah, it sounds like a kind of a cool, different design. How big or how small can a flow battery practically be? And, are they ever going to replace residential lithium-ion batteries for storage? Is that on your product roadmap?
There's definitely a lot of interest in it. Our smallest footprint right now is a 40 kilowatt hour battery, which is probably a little bit bigger than most people are going to want to have on their homes. That's primarily because we've been focusing on sort of commercial and industrial applications. Within 2 years, I think there are going to be options for vanadium flow on residences. I'll have to suggest to that waits the news on whether that's from us or some of the other people we're working with.
All right, that makes sense. All right, so it sounds like these flow batteries have a tremendous amount of potential. What are the lifetime issues with a flow battery, and what are the disposal issues with flow batteries? Because disposal is kind of coming up on the PV side. I'm wondering about how we deal with disposing of flow batteries.
So I'm really happy you asked about that. One of the things that I think is so great about these batteries is the disposal aspect of it. We talked earlier about how the vanadium itself retains its value throughout the life of the product. And, when you 20 or 30 years down the road decide you want to retire this thing, take that vanadium and, sell it back to someone who's going to repurpose it into something different. The rest of the battery is literally, I would say, 98% of it you could recycle in your curbside recycling bin. It's made up of very standard commodity materials like polyethylene, like steel, like aluminum. And so, the recyclability at end of life and the disposal of it at end of life is really a massive difference between this technology and a lot of the other battery solutions on the market.
So I'm just kind of conceptually thinking you got a couple of tanks or one big tank, you have an anode, you have a cathode, you've got an inverter. There must be pumps that are pumping the electrolyte back and forth. Is that something that's going to need maintenance over that 20 or 30 year life of the system?
It really depends on how much you're using the battery. The pumps we use, they're designed for something like 80,000 hours worth of operation. So if you're running the battery 24/7, that means that after about 10 years, you might need to replace those pumps. But practically speaking, in most applications, you're not going to be running the battery 24 hours a day. And so if you think about, an application, for example, where you're, self-generating your own electric power off of PV in the middle of the day, and then you want to use the battery to cover a load in the evening time, that means your battery's probably going to be operational for sort of 6 to 8 hours. That means you're going to get 20 to 30 years out of components like those pumps.
Yeah. All right. Not a big deal. I mean, everybody's done the replacement of not everybody, but, they've replaced water pumps and hoses and things like that in their cars. Yeah. But, thinking about cars and trucks, are there any transportation issues or size limitations with flow batteries? Because I know that for the larger lithium-ion systems, there's some hazmat issues that we have to address.
Right. And one of the things that we've done at Avalon, which is different than, what every other battery manufacturer, both flow batteries and lithium batteries are doing today, is that we ship our battery in a 100% fully turnkey configuration, meaning that it is in a fully functional state when we ship it. There's no need to add the liquid electrolyte after it arrives on site, or as we see with some lithium solutions, there's no need to install the battery packs after the overall assembly arrives on site. And we've been able to do that by essentially going through, adding a lot of techniques and technologies into the design itself to make it absolutely safe for road transportation.
Okay. Now, when we're looking at doing solar installations, residential and commercial, we care a lot about the inverters and the software. What systems, inverters and software, are compatible right now with your Avalon flow batteries, and what's your roadmap to add additional inverter partners?
Sure. So right now, our most common partner on the inverter side is a company called Ideal Power out of Texas. What we like about Ideal is that they make a very capable 3-port inverter that allows us to connect both the battery and the solar into a single box, saving money, saving time, and saving on sort of the amount of installation work that's needed. The standards around battery inverters and power electronics and around battery controls are evolving very, very quickly, as the whole storage market is evolving very quickly. And there are, emerging standards around both, the sort of interconnection voltages and around control protocols that go along with batteries like these. We essentially are compliant with all those standards. We usually will, if someone comes through the door and wants to buy one of our batteries, we can certainly recommend an inverter or control solution. But if you have a particular inverter you want to work with or a particular energy management system provider who you think does a great job, we can certainly integrate with those people without too much trouble.
Yeah, so that flexibility, I think, works really well for really big systems and big commercial systems, things that might be custom designed. When we get down to more standardized, very standardized residential and commercial systems, there's all kinds of UL requirements. So what are the UL requirements that apply to your flow battery?
Yeah, so, the standard for batteries like ours is called UL 1973, the standard for stationary batteries. We are currently compliant with those standards. I can't say definitively, but, I think within a very short period of time, we'll be announcing that, we have completed all of the testing that is required to be formally listed as a battery under those standards.
Right. Yeah, you characterize that properly. Nobody who's been through this before would ever put a defined timeline on when they'll get their UL certification. I basically just, listen and however many months or years I double it. It just takes forever. They make stuff up. But that's good. And I'm sure that the system's going to work. It's pretty simple, which I really like about it. In terms of the complexity, what kind of software or firmware controls are required for a flow battery? Or is it basically the same as you'd use with lithium ion, just different parameters?
Very, very similar to what you'd see for a lithium array. In terms of the dispatch and control of the battery that the energy management system will be doing, our goal is to make our battery look like a black box that's like every other battery black box. You send it commands around, power or charge, and it will comply with those commands. What we do inside our battery is we've got, our own battery management system, or BMS, that manages all of the internal functions of the flow battery, including, running the pumps and, managing the state of health of the battery, providing external monitoring of some key performance parameters. That BMS is something that, we take on ourselves, and, we provide the key performance parameters out of those devices for our users. But there's no need for anyone to actually interface with the internal components of the battery directly. The BMS does all that for you.
Good. I hate this term. We're going to use it because it comes up. Is your flow battery bankable? And if not, kind of what's the timeline for that? By the way, I just hate the term bankable.
Yeah, look, bankability is, as my engineer's brain, one of the things that I hate about it is that it's always subjective, right? One person's definition of bankability is different from another. To me, it means that, what you have is independent validation of three different things. That your product works the way you say it will, that your product is safe, and that you as a company are able to stand behind your warranty. And on all three of those things, we've now checked what I think are kind of the key boxes. We've had independent engineers, including DNVGL, probably one of the world's largest independent engineering reviewers, come in and do a technical assessment of the battery's performance, and not on the lab bench, but at scale and in the field. And they've validated that, it has the ultra-low degradation rates that we talk about. On the safety aspects, to your point about UL, we've been through those hoops now and can concretely point to us having met all the requirements for ensuring adequate safety as embodied in those UL codes. And then on the standing behind the warranty side, not only are we able to point to some of the great partners that we have in, building and reselling these things, but we also now have a couple of major international insurance providers who are willing to stand behind that warranty as well.
Yeah, getting that third-party insurance is really, really key, and I've seen other companies do that successfully. It really helps.
Well, absolutely, and you've been on the pointy end of this in solar space, where, that warranty insurance in the early days of solar was so critical to getting, the kind of financing that people needed to start building these big solar systems. Yeah. And, we're now through that hoop as well.
How did you get started at Avalon?
So I've been building flow batteries for 13 years now, and first with a company called VRB Power Systems back in 2005. VRB Power was the original licensee of the vanadium flow battery technology into North America. We were acquired in 2009, and then in 2013, myself and a bunch of my current colleagues were looking at the way that electricity markets were evolving. And at the time, we were deploying these vanadium flow batteries for very large sort of utility services type installation. And we thought that there was a more interesting opportunity to take the same fundamental technology, the same vanadium flow technology, and repackage it in a way that it was suitable for both solving problems in terms of individual electricity users, electricity consumption, so-called behind-the-meter storage application, and also for, solving some of the problems that come when you try and integrate, very large renewable generation projects on the grid, the sort of front-of-meter, utility generation management aspect. So myself and my two co-founders, and then eventually, a whole technical team came with us. We spun Avalon out of our former company with the goal of repackaging that vanadium flow technology for exactly those kinds of applications.
Yeah, wow. It looks like it's working, and it really does solve a really big market need in terms of something that's got that longer capacity and better durability. How can people get in touch with Avalon?
So find us on the web, avalonbattery.com. There's an email address there, but it's, connect@avalonbattery.com. That goes straight into my inbox. Would love to chat with any of your listeners on, how a long duration, long life battery like this might make sense for them.
All right, terrific. Well, that's all the time we have on this week's Energy Show. Thanks, Matt, for joining us. And thanks to all of our listeners for tuning in. If you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.